calling it a paradigm because, again, it needs to be established. It's just, the change is just happening now. And I've been promoting it in now the scientific community and now in the cancer patients, early cancer patients. So this is where things stand.
So since you're familiar with these two conditions, and you can say one is more aggressive early onset, one's late. Does anybody else list at all? Is there any continuum of all the mutations? Like, can you look at your report and you see, oh, I have this, and so it's less earlier onset or later onset? Is there anyone else looking at that? Can Athena tell you that, or do you understand my question?
I think that will happen with see how much it's let me see, it's yes, the European group did it. As I told you, they reproduced the data using but they couldn't really get, there are not that many patients that have these mutations in the core side. There are very few. Shows or tells a little bit about what's going on. They are more severe, you know what I'm saying? But they were able in Europe to do this. Now, since the paradigm is only shifting, I think now people are going to look back and try to see if we can really get a very good correlation. Let's say we have here, age of onset. Can we really see something like this? At the moment that, this is years. Oh, no, actually, I think it would be better to say like that. We're thinking charts, but might not be. It could be really that the moment that you have, this is the rescue, and let's say one of these is activity of NOSH3, and then this is at the moment that activity decreases, the age of onset is actually late. So this is time without the stroke. Can I really say that? I'm getting confused now.
Yeah.
Okay, so it works. So that hasn't been done because that's the moment. The moment that a paradigm shifts, then everything is now looked at back against the new paradigm. But we just got the paper out in March, so that's only happening, and I think it's going to gain even more power after these new reports of people with stroke, inherited stroke, that just don't have NOSH3. That's just going to take, because then people don't even have to think about it. If this the way we did it, people have to think about it. They have to be, okay, so this mutation is this, and that mutation is that, and then in the chart, this happens, and the bar, and this and that. Now, a lot of people, even scientists, they don't want to think about it. They want to say, well, I just want to see that the gene is not there, which took us up until now. So it is something that is in the works, and that's I think as much as, I don't want to say too much about, we have this thing that is called personal communication between scientists. So these reports that are published are personal communications. So I cannot just, and because it's not my work and I'm not involved in them, I cannot tell you more about it, or who is involved or who is not, because it will be lack of loyalty for them. I don't know, some people, what they like. About my data, I've told you everything, but that's just the way I operate. I'm not holding anything. Someone else's data is their data. But as soon as these papers come out, I think this idea is really gonna, they are already being reviewed, I can tell you that. Don't think that those papers are like, no, yeah, get out. So they are in the peer review process. They are in the process where people look at them, and I tell you, the people that have the established paradigm, I'm looking at them right now. So let's see how, I'm not involved, but I wish them luck.
So we may have that be related to how old the patients were and which mutation they had? So maybe,
The thing is with
maybe
ADISEL,
something like L-arginine or Aricept or some other drug or supplement might work really well for one person and not well for somebody else because of their mutation or
well, that
because
is
of their
true.
age of where they are. Or,
That is true, although I don't know, and I think we'll have to be tested. I can assure you one thing. No one has probably looked at how Aricept or the arginine affects NOTCH3 signaling because it wasn't part of the paradigm. One thing that can be done is all these supplements, and people can do research on them. Maybe it will be difficult to get funded, but people can say, okay, how do they affect signaling? Because not everything has to be tested against that. You know, I looked it up. There are some Chinese drugs that have been used for stroke for thousands of years, and then someone reported that they affect NOTCH signaling. You know, it's like, okay, well, that's interesting. That's coming handy sometime down the road. Am I thinking of a clinical trial using that? Oh, yes. And I have the patients in Colombia. I think here it would be, they are spread, there they are not. So will that be the, you know, if I can think about the problem with, that's the problem. The problem with natural products, this is something that you should know because this is like something that people talk about. They feel they can, because on the web and everything, is that it's very difficult to do research on them. But it's a natural product. You know, it's not done, every lot is not the same. Where do you get it from? How many, you know, what's in it? If it comes from a plant, and the plant that they had sun and the other one didn't. So that's what makes different. That is not just the thing. It's just not the idea that people can make money out of it. That is true, but it's also the idea that natural products are difficult to do research with just because research works in a different paradigm. But there are things that we can test that affect NOTCH signaling, and we can now see. I don't think Aricept is a different drug. It affects actually acetylcholine, is that correct? So it's that's the target. We need, that is the thing. If you think about, we are thinking of, and I defined, you know, when I was defining my target, it's a career goal, I'm looking for a cure. When you are into drug development, what you need is a target, a protein, a molecule that is your target for, and so now, I think if you say here, what is the CADASIL cure? Before, it's very unknown. How can we target something we don't know? It's the alien sample that I told you, we don't know. How can we target it? But now, the target is NOTCH3 signaling. Then I can tell you that a lot of people can, not just me, can think of some ideas about how to increase NOTCH3 signaling. But a lot of other people smarter than me can also think about it. Because it's a targetable, we know what it is, we know how it works. Well, a lot of people can jump on it. This is why it's now published. So it's testable and it's doable and it's out there. So that is, I think that is the hope. And this is why, because I think it's related to stroke, this is why it gives us the hope. And I think, I don't think, and this is, I'm very familiar with the concept, and I'm going to borrow from a different disease. But there is a current effort led by American scientists and Colombian scientists, and is funded through American foundations, and a lot of money is going into Colombia for something that is called Alzheimer's prevention. It's the API, the Alzheimer's Prevention Initiative. And a lot of people, have you heard about Alzheimer's treatment? Yes. Have you heard about Alzheimer's cure? Yes. Have you heard about Alzheimer's prevention? Maybe not. And this is the thing. Can we? And this is if a problem has to do with NOTCH3 signaling, and that